Displacement versus total change. You guys should be able to tell me the difference between these based on what we've done already, but we're going to go back a little bit and relearn it, rehash it a little bit, maybe write it down in a formal form. What does displacement mean? The change in position, right? It's a change in the position. Okay? Or it's displacement, it's how many flies were added to the system or taken away from the system overall. Okay? What's total change? Maybe how much the particle had moved altogether. So if it moved 10 miles to the left and 5 miles to the right, what's its total change? 15. What's its displacement? 5 to the left, right? So there's a difference between the two, and we obviously approach them in different ways. Okay? So let's see if we can remember how to do this. This goes back to first semester. How do you know when a particle is moving to the left or to the right? Okay. So when the velocity is negative, the particle is moving to the left, and if the velocity is positive, the particle is moving to the right. So let v of t equal t squared minus 8 over t plus 1 squared be velocity from 0 to 5. I want you to tell me when it's moving to the left or moving to the right. So I'll give you a couple minutes to do that. So that's just saying what we just said. The particle moves to the left when v of t is negative, and it moves to the right when v of t is positive. Okay, what's the first thing we have to do? Well, we got to find all critical points, right? What are the three types? Endpoints, zeros, and does not exist. Now, are we taking the derivative of this and then finding the zeros? No, because this is the derivative in a sense, right? So we're going to set it equal to 0. We're going to figure out where it does not exist, and we're going to look at the endpoints. So what's the first set of endpoints that we have, or first critical points we have? 0 and 5, because those are endpoints. What other critical point do we have? What? The zeros, right? But before that, what's another critical point based on the equation? So where is it? What? -1, right? Because can't divide by 0. But that's outside the domain, right? So we're good with. We don't have to worry about that one. But you do have to consider it because sometimes it won't be. So 0, now we'll set it equal to 0 and solve. If this is a calculator problem, I see a lot of you guys doing analytical work because I didn't tell you to use your calculator till later. But how would I figure that out? You don't even have to do that. It's a calculator problem. Type it in your Y list and find your zeros, right? Okay? Yeah, you could add the 8s over 2 plus 1 squared, cross multiply, but it gets gross. You get t equals 1.255? Okay. So that's our other critical point. Now we set up a number line for velocity. What is the sign of velocity from 0 to 1.2? Negative, and from 1.2 to 5? Positive. So therefore we could say velocity is, we could say the particle is moving what? Moving left from 0 to 1.25, since velocity is negative. And then it's moving to the right from 1.255 to 5 because velocity is positive. Therefore, just going back a little bit more, what can we say is happening at t equals 1.255? There, yes, but more than that. It's changing direction, yes. Okay, so velocity is changing from negative to positive. Therefore, the position is changing from decreasing to increasing, therefore making what? A minimum, which means, conceptually, what does that mean on the number line that we're dealing with? The particle is furthest to the right at that point, right? What is when t equals 0, what is it? Come on, at t equals 0. It's a relative maximum, and at t equals 5, relative maximum again, right? You guys okay with this? Didn't sound like it. Okay. But now let's look at the idea of displacement in terms of that. So we said that a minute ago, but the distance the distance a particle has moved away from its original position. So we have to include the signs. What's another word for saying displacement? In terms of the basic, this is the application of what we've been talking about. How are we going to approach this? How are we going to find displacement? Do you need to know the initial condition to figure out the displacement? It's a good question. No. The displacement is just how far you are from where you started. Do you need to know where you started to know how far you are from where you started? Not necessarily. But what mathematical operation are you doing to find displacement? What? Well, I think bigger than that. What did you say, John, a minute ago? The net what? The net area. What's it called? What are we finding? The integral. Thank you. Oh my goodness, this is like pulling teeth. Okay, so displacement is determined by the definite integral. So we need to know the bounds. We need to know our lower and upper bound. What is our lower bound usually? Yeah, it's a constant, but what does it represent in the context of the problem? The starting position? No. Talking about integral, those variables are what? Yeah, you could say x values, but when we're talking about displacement, position types of things, it's not x, no. Because if we're talking about position, x of t, what does x represent? Position, what's t represent? Time. So what am I taking the integral of in order to find displacement? Am I taking the integral of position? Velocity. So what are these values? These are time values. So what is the lower bound? The starting time. Not the starting place, but the starting time. It could be 0, or it could be wherever I'm saying, what's the displacement from here to here, kind of thing. Okay? So let's see what we got here. We don't need the initial position. We don't need to know where it began. We just need to know what time it began, in a sense. So how would I find the displacement? Same equation we dealt with. How do I find the displacement? If velocity is given over 0 to 5, how far is the particle from its original position when t equals 5?
Oh, wait, no.
Where did it start? At what time did it start? 0. And we're looking for its displacement when t equals 5. So what's the equation? Okay, so figure that out for me real fast. This is why you save that velocity function in your y-list. Okay, what'd you guys get? 35. What does that mean? That means the particle has moved 35 units to the right from where it initially started, right? Does that mean that the distance that the particle traveled is 35? No. This particle, and you saw in our previous problem, what did we see in the previous problem? We saw, same thing, same scenario, same domain, that from 0 to 5, which way did the particle go? No, what do we look at? When was velocity negative? It went from 0 to like 1.255 or whatever. The particle was moving to the left. And then from 1.255 to 5, it was moving to the right. So does this mean that the particle traveled a total of 35 units? No, it means here's where it started. It moved over here, and then it moved back over here. Therefore, it's 35 units from where it started, right? And so if we look at the velocity graph would have looked something like this, right? Where this was what point? 1.255? Okay? So the velocity was negative, therefore the particle was moving to the left, and then to the right. But since this is a 35, a positive value, what does that imply about these areas? This area is going to be bigger than that area because it moved further to the right than it moved to the left altogether. Does that make sense? Okay.
Increasing represent.
Well, this is velocity graph, right? So if velocity is increasing, what does that imply? Right. So acceleration would then be positive, and that would imply position or displacement, or however you want to say it, is concave up, which doesn't really do much for this context. All right. So we would say that the particle is 35 units to the right from where it started, or it moved 35 units to the right over the time interval 0 to 5. Can I go on? Wow. Okay. What's the difference between displacement and position then? If I want to know where I'm at, or where this particle is at when t equals 5, when t equals 5, it moved 35, from 0 to 5, it moved 35 units that way. But how do I know where it's located? I need to know where it started, right? I need the initial condition, okay? So what would be a good equation for that? Initial condition. Well, I'll even make it simpler than that. The position of a particle is the initial condition plus displacement, right? You guys okay with that? Where did I start, and how far did I move which way? So now let's put the calculus in it. What would that look like? If the t was 0 when we started, in our problem that I gave you, that's true. Maybe. I'll write it like this. What is that? What does x of b represent? The position when t equals b is equal to the position when t equals a plus the integral from a to b. So we know the position at a certain point in time, and then we added how far it moved away from that position from that time to the point I'm concerned about. You guys okay with this? It's nothing new, is it? Just writing it down formally, I think. Okay. I hope not. So, same problem. I want to know the position when what? What else do I need? Let's see. So here in this problem, I had to give you an initial condition. I had to give you its position at a certain point in time. Otherwise, I couldn't find the position. Okay? What is the position when t equals 5? Go ahead and figure it out. Okay, what's the equation? 9 plus integral from 0 to 5 v of t dt, right? So the position when t equals 5 is equal to the position when t equals 0 plus how far the particle moved. Right? So we would say 9 in this case, plus the integral from 0 to 5, which we already figured out. The integral from 0 to 5 was 35. So we can say the position is 44. A generic equation, and that's kind of generic in a sense, but it's at certain values, we would say x of t is equal to what? How do we say this? X of, we'll say 0. Does that mean, I put the 0 down here. Does that mean that t equals 0? No, it means whatever t is when I start, this is the initial position. Plus the integral from, actually, what's a better way of saying this? Let's say x of I. What is that? Initial. Well, maybe this would even be better. X of ti. How about that? So x of the time, at the initial time, right? Plus what? The integral from ti to t of v of, we don't want to use t. V of, well, we don't want to use x. How about r? Whatever. Just as long as it's not a variable in the rest of the thing. Are you guys okay with this? No, you didn't pick my letter. I give up. Yes.
Will the quiz be tomorrow?
No. No, there's a homework. Look at your homework log. The homework log has it on there. 6.4b was not the last one. I think 7.1 is next.
Oh yeah, because it said
On the homework list I passed out, the whole thing, for some reason, those three, the next three assignments are in the next unit. But if you look at your log, it's the correct ones. That's a good point. Okay. Total distance. So now we've got to compare the idea of position, displacement versus total distance. What is total distance? All the distances, total. Thank you for just rearranging the words. That makes sense. What's that? Okay, we're combining those values. So we said it a minute ago. If the particle moves this way 10 units, and the particle moves this way 5 units, what's its displacement? The displacement is -5. Its total distance is what? 15, because it's 10 plus 5. So what? There you go. Absolute value, right? You remember this from a while ago? So what would the equation be for that? The integral from something to something, whatever our time domains are, of the absolute value of v of t. Okay? No. All right, the distance traveled to the left plus the distance traveled to the right. And so if we go back to our previous example and looking at that graph, if I'm finding the total distance traveled, if this is v of t, if I'm trying to find the total distance traveled, this value is going to tell me what? How far the particle moved that way. And then this value is going to tell me how much it moved that way. To figure out how much it moved overall, what do I have to do graphically? I have to kind of flip that up, right? So make this positive, right? And the way we do that is we say the integral of not v of t, but the absolute value of v of t. From whatever those points are. Do you need an initial condition for this? No. If I want to know how far the particle traveled, do you need to know where it started? No. The only time you need to know where it started is to figure out where it's at, right? All right, so total distance from A to B is written as the integral from A to B of absolute value of v of t dt. Okay? So let's look at the same equation. I want you to find the total distance traveled from 0 to 5 using your calculator. Go. All right, so what do we get for total distance traveled from 0 to 5? Okay. So it's the integral from 0 to 5 of the absolute value of that function. And you got 42.589? Okay. That's what I got. I don't know. 5869? So 587. Okay. It's 587. Sorry. Minus a point. Why? Because I want everybody to think I'm perfect or something? Right, so I cut it out of the video so that people don't ever discover that I'm ever been wrong. That way I look smart. So what's the difference between displacement and total distance? Displacement is, again, it's canceling out the negatives with the positives and seeing what's left over, right? So we say the equation was just the integral from A to B of v of t dt. Total distance is combining all the negatives and the positives, right? To get a total distance traveled. So you have to take the absolute value of all the negatives and the absolute value of all the positives. And so we get the integral from A to B of the absolute value of v of t. This is really application heavy. When you get to FRQs with a lot of application involved, this is what would I ask for if flies were in a jar? What would the integral of v of t represent here? So if that answer was -5, that would imply that there are 5 less flies in the jar at this time than when we started, right? If it was +5, then there are 5 more flies in the jar than when we started, okay? But the second one, the total distance, same context, flies in a jar, what's the integral of the absolute value represent? How many flies basically cross through the jar's lid? Right? So 3 flies went in, 2 flies went out. Then the total distance, in a sense, would be 5, right? Whereas the displacement would be what? 1, because there's 1 more in there. Does that make sense? Okay? In the context, graphical context, what do we say the integral or the displacement is? What does it mean graphically? We're finding the what? The net area. And in the other one, we are finding the total area. All right? Are we good with this? All right, you guys do this one. Okay. First one. A. How do you know when the particle is moving left or right? Set it equal to 0, find all the critical points, blah, 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 blah. What are the intervals for when it's moving to the left?
3.295.
So left from 3.295, is that what you said? Is less than t is less than 7, right? Since v of t is greater than 0 over this interval. You guys okay with that? And then right. Sorry, v of t is less than 0? Sorry about that. Moving to the left when velocity is negative. So what is it? Right from 0, 3.295, since v of t is greater than 0 over that interval. Okay, I'm not going to dwell on that. How far is the particle from its initial position? Is that displacement, is that position, or is that total distance? That's displacement. So what's the equation? Integral from 0 to 4 of v of t dt, right? Which is? 7.
Oh, it's initial position x equals 4.
How far is the particle from its initial position? Its initial position is 0 to t equals 4. Okay, so what is it? Huh? That's it? 24? Okay, so 24, there we go. C, where is the particle at when t equals 6? Is that displacement, position, or total distance? Position. So what's position there? That's going to be, what's the equation? We're missing something here. Initial condition, negative 32, plus the integral from 0 to 6 of v of t dt. Okay? The initial point was negative 32. All right, what do we get?
It's negative 92.
Negative 92? Even? Done? Wow, maybe we could have done this without a calculator. When is a particle when t equals 6? So it's 92 units to the left, if that's the context. And then part D, what is the total distance traveled? How do we figure that out? The integral from 0 to 7, absolute value of v of t dt. Remember, you do not want to put the absolute value of the integral. That is not... That's just changing the sign, or that's just making the sign of what? Positive. That just changes the sign of displacement. That doesn't tell you the total distance. So what do we get here? 226 point what? Okay. Oh, I should ask this. Is total distance, can that ever be negative? No, because if you're saying how far did something go, it's always a positive number, right? So even if you ended up, well, you wouldn't get a negative number anyways because that's absolute value, but